Do you want to know what it is? The matrix is everywhere. It is all around us. Even now, in this very room. You can see it when you look out your window or when you turn on your television. You can feel it when you go to work, when you go to church, when you pay your taxes. It is the world that has been pulled over your eyes to blind you from the truth.
The Matrix is everywhere. It's all around us. Even now, it's in our eyes. Whistler from the 1999 movie The Matrix tells us that the Matrix is everywhere, influencing our daily lives, even if we're not aware of it. Hi, I'm Sander, and today I'm going to tell you everything all about matrices, how to add, subtract, and multiply them, and also some of their applications in real life. That's what I'm going to talk about today. What is a matrix? A matrix is a rectangular array of numbers or equations arranged in m rows and n columns, encased in brackets or parentheses. These are the elements of a matrix. They are rows and columns. In this example, there are 2 rows and 3 columns. Therefore, it is a 2 by 3 matrix. Here are some examples of matrices. The first one is a 3 by 2 matrix. The second one is a 3 by 3 matrix. The third one is a 2 by 2 matrix. The fourth one shows a 2 by 1 matrix. This shows that matrices can be any size. Here are the types of matrices. They are row matrix, column matrix, square matrix, rectangular matrix, identity matrix, and a zero matrix. Here is an example of a row matrix. A row matrix is a matrix with only one row. Here is an example of a column matrix. A column matrix is a matrix with only one column. A square matrix is a matrix with an equal number of rows or columns, just like a square. Here are some examples below. A rectangular matrix is any matrix that does not have an equal number of rows and columns, just like rectangles. Here are some examples below. An identity matrix is a square matrix with ones on the diagonal and zeros elsewhere. Here are some examples below. A zero matrix is a matrix of any size whose components are only zero, no other numbers. If matrices are just bunched up numbers, can you add or subtract the matrices? Yes, you can, and here's how you can do it. Part 2. How do you add and subtract the matrices? To add the matrices, you first get the number, second, add it to the number that is in the same position in the other matrix. Third, put the sum in the same position in the answer. Fourth, repeat for all the other positions in the answer. You can add together any size of matrices. For this next example, we're going to use 3 by 2 matrices and then add them together. The resulting is just the addition of all the elements of each matrix. We've already talked about how you can add and subtract the matrices, but there's one more operation you can do on them. That's multiplication. In part 3, we can learn how do you multiply the matrices. Part 3. How do you multiply the matrices? As you can see, the way to multiply matrices is very complicated. Luckily, there is an easier way. As you can see in the example, we have to multiply the matrix 1, 2, 3, and 4 by 5, 6, 7, and 8. And they're both 2 by 2s, meaning we can multiply them. For the first step, you take the top row of the first matrix. For the second step, you also have to take the first column of the second matrix. And then in the first matrix, take the leftist number on that row and multiply it by the most top number in the second matrix on that column. Multiply them, and then for the first matrix you have to go right, and for the second you have to go down, and you have to multiply those together. After you get all the products, you have to add them. For the first matrix, we put it in the top row, and for the second matrix, we put it in the leftist column. So we take the leftist column and the top row and put it where when they both intersect. And then you put the sum there, and then repeat for all other columns and rows in both the matrices. Then after doing all that, you get the product of those two matrices. All that matrix operation stuff is cool, but what are the applications in real life? All of that will be shown in part 4. Part 4. The application of matrices in real life. Application of matrices in computer science are image processing, data analysis, machine learning, computer graphics, and network analysis. The application of matrices in economics are input-output models, linear programming, econometrics, game theory. The applications of matrices in data analysis, they are statistical analysis, data visualization, principal component analysis, aka PCA, singular value decomposition, aka SVD. Here are some real-life examples. They are Google's PageRank algorithm, Facebook friend suggestion algorithm, image recognition in self-driving cars, predicting stock prices, analyzing medical images. Matrices play a crucial role in Google's PageRank algorithm by providing a compact representation of the web graph and enabling efficient computation of PageRank scores through matrix multiplication and iteration. Just like Google Search, matrices play a significant role in Facebook, specifically in Facebook friend suggestion algorithms. By applying matrix factorization, matrix operations, and machine learning techniques, Facebook's friend suggestion algorithm can recommend friends better based on user similarities and behavior. The advancement of computer vision technology has given us image recognition tech, like facial recognition in self-driving cars. Image recognition has revolutionized the way we interact with machines. Matrix algebra plays a crucial role in image recognition. When a machine receives an image, it breaks it down into its individual pixels, which are then represented by matrix elements. The machine then uses matrix algebra. The operations in matrix algebra include convolution, pooling, and flattening. So that's it. I hope you learned something about matrices and some of its applications in real life. Bye! Thanks for watching!